February 20th, 1943, north of Kasserine Pass, Tunisia. The official battle report would never truly capture what the German tank commanders witnessed that morning. American Sherman tanks were executing maneuvers that defied everything Wehrmacht doctrine claimed was possible without visual signals. Through the swirling dust and smoke of the North African battlefield, 5 Sherman tanks, separated by broken terrain with no line of sight between them, converged on German positions with timing that seemed almost supernatural. No flags waved, no flares ignited, no dispatch riders raced between vehicles. Yet they moved as a single organism, each tank covering blind spots the others couldn't see. Every crew appeared to know precisely where their comrades were located. In the German Panzer IVs, equipped with FUG-5 radios, commanders struggled to hear their company leaders through static that overwhelmed their amplitude modulation systems. The 10-watt German transmitters, state-of-the-art by 1930s standards, could barely transmit over a few hundred meters when tanks were in motion. Most German tanks carried only receivers, unable to report what they saw or call for assistance. Meanwhile, the Americans were operating with technology the Germans didn't even know existed. Each Sherman tank was fitted with a frequency modulation radio, crystal-controlled precision, 25 watts of transmission power, and clarity that cut through engine noise and battlefield chaos like a knife through paper. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself. It wasn't about armor thickness or gun caliber, but about invisible electromagnetic waves that connected every American tank crew in a way the Wehrmacht never imagined possible. The transformation had begun on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were advancing through the Soviet Union using tactics that depended on limited radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render German systems obsolete. The engineering team included Daniel E. Noble, who first conceived the use of FM technology in military vehicles, and Henrik Magnuski, the principal RF engineer who solved the immense technical challenges of installing sensitive electronics inside the harsh, vibrating environment of a tank. Their creation, weighing 181 pounds, transformed every Sherman into a node within the world's first battlefield network. The BC-604 transmitter generated 25 watts of power 2.5 times more than the German FUG-5's output. Operating in the 20.0 to 27.9 MHz frequency range, it offered 10 preset channels with crystal-controlled stability. Dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat. The real revolution lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed to the U.S. military, eliminated the static and interference that plagued amplitude modulation. While German tank radios picked up every electrical discharge as noise, American FM radios delivered crystal-clear voice communication even amid artillery barrages. When Operation Torch began on November 8, 1942, American armor landed in North Africa with a communication advantage the Axis had never seen. The 2nd Armored Division's tanks came ashore near Safi and Fedala, equipped with SCR-508 radios that soon demonstrated their superiority. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under severe communication limitations. A standard German tank platoon of 5 vehicles included only 1 or 2 with full FUG-5 transceivers capable of both transmitting and receiving. The others carried FUG-2 receivers only. They could hear orders but couldn't reply or report enemy positions. German platoons functioned through rigid hierarchy. The platoon leader transmitted orders and subordinates acknowledged them through action rather than speech. When command tanks were destroyed, easily identified by their multiple antennas, entire platoons lost coordination. This vulnerability would prove catastrophic when facing American forces, where every tank could assume command functions. The Battle of Kasserine Pass, fought from February 14th to 24th, 1943, provided the first major demonstration of American radio superiority. Although tactically a German victory, the battle revealed capabilities that astonished Wehrmacht observers. During the confused fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across nearly 50 miles of battlefield. Tank crews who had never met in training coordinated attacks, warned each other of threats, and called in artillery support through clear FM communications. German signals intelligence units intercepted American transmissions and were struck by their clarity and organization. The 10th Panzer Division's intelligence section noted that American units maintained communication at ranges where German radios produced only static. More alarming was the realization that every American tank appeared to have full transmission capability, not just the command vehicles. German FUG-5 radios, operating on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental design limitations. Their 10-watt transmitters struggled to reach 2 to 3 kilometers under ideal conditions, often dropping to mere hundreds of meters when vehicles moved. Every spark plug firing, every motor turning, every movement of the tracks generated interference that AM systems could not filter. In September 1943, American armor arrived in Italy. The mountainous terrain should have negated radio advantages, but instead, FM technology proved even more valuable. The SCR-508 handled the multipath interference of mountain valleys far better than AM systems. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely during the advance toward Cassino. American armored units demonstrated capabilities that defied German understanding. Tank platoons separated by ridge lines coordinated attacks with precision that German doctrine said required visual contact. After-action reports from the 1st Armored Division described routine coordination at distances where German radios produced only static. By June 6, 1944, as Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with naval fire support, a feat impossible for German technology. Yet the hedgerow fighting revealed a critical weakness. Tank radios couldn't communicate with infantry units, whose SCR-300 radios operated on a different frequency range, 40.0 to 48.0 MHz versus the tank's 20.0 to 27.9 MHz. This communication gap proved deadly in the Bocage country, where German infantry armed with Panzerfausts could sneak up on American tanks while nearby American foot soldiers had no means to warn them. The solution emerged within weeks. Tank crews mounted EE-8 field telephones inside ammunition boxes welded to the tank's exteriors, wired directly to their internal communication systems. By the time of Operation Cobra in late July 1944, this simple yet ingenious modification revolutionized tank infantry cooperation. Between July 25th and 30th, Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, under Major General Edward H. Brooks, coordinated over 200 Sherman tanks through seamless radio networks, achieving a level of battlefield control unseen before. German defenders from the Panzer Lehr Division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by units miles away, and artillery strikes coordinated through tank radios arrived within minutes of target identification. The contrast with German forces could not have been starker. Once considered Germany's elite, Panzer Lehr had been reduced to communication poverty. Most tanks operated without functioning radios, relying on visual signals in terrain, where visibility rarely exceeded 100 meters. The few radios still operational suffered from interference and limited range that crippled coordination. The irony was profound. Germany had pioneered the use of radios in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had championed radio equipment in tanks since the 1920s. His 1937 book Achtung Panzer emphasized communication as essential to armored operations. Guderian developed radio systems that allowed officers to coordinate their attacks. He understood that rapid advances depended on reliable communication. Yet by 1943, German industry could no longer produce enough radios to equip its expanding tank force. German production statistics revealed the depth of the crisis. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Many of these limited radios were allocated to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Soviet tank forces faced an even worse communication deficit. The T-34, though the most produced Allied tank, typically entered combat without any radio equipment whatsoever. Soviet doctrine depended on pre-battle planning and flag signals, a disastrous limitation that cost thousands of lives against German forces during the 1941 invasion. By 1943, Lend-Lease aid from the United States partially alleviated this shortage. American radios, including SCR-508 sets, began appearing in Soviet command tanks. Yet even by the war's end, only about 25% of Soviet tanks carried radios. This contrast underscored America's astonishing achievement. While the Soviet Union struggled to equip a quarter of its tanks with any form of communication, the United States achieved a 100% deployment rate of sophisticated FM systems across its armored fleet. Motorola's Chicago factory symbolized American industrial mobilization at its zenith. Before the war, the company specialized in car radios. Converting its production lines for military use required complete retooling and the solution of unprecedented engineering challenges. Each SCR-508 radio required precisely 2,148 individual components manufactured to exacting standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain perfect frequency stability despite the extremes of battlefield temperature and the violent vibration of tank movement. Production statistics told the story of America's industrial might. In 1942, 3,800 SCR-508 family radios were produced. In 1943, 11,400, and in 1944, production reached 24,000 units. By the war's end, more than 50,000 complete tank radio sets had been built enough to equip every one of the 49,124 Sherman tanks manufactured during the conflict. No other nation came close to achieving such a feat. The advantages of the SCR-508 extended well beyond the basics of frequency modulation. Crystal-controlled frequency stability allowed tanks to preset channels before battle and maintain exact alignment even under combat stress. German Fuji 5 radios, dependent on variable capacitor tuning, drifted off frequency constantly. American dual receiver configurations meant commanders could monitor their platoon net and company command net at the same time. Orders flowed instantly down the chain of command, while situational awareness flowed up with equal speed. The BC-606 intercom system integrated seamlessly with the radio, allowing every crew member to alert the commander to threats. Throat microphones and noise-canceling headphones enabled clear communication even inside roaring metal hulls. By contrast, many German tanks lacked intercoms entirely, forcing crews to shout or rely on physical contact during battle. Power management added another layer of American advantage. The SCR-508 could operate on either 12 or 24 volts, automatically adjusting to whatever power supply was available. Its dynamotor power unit provided filtered stable current that eliminated electrical interference. German radios, powered directly from the tank's electrical system, picked up every spark as a burst of static. This universal radio deployment transformed American armored doctrine. The U.S. Combat Command structure, built around flexible task forces assembled for specific missions, depended entirely on reliable communication. Commanders could form ad hoc battle groups from different units, confident they could coordinate seamlessly through standardized radios. German commanders, constrained by limited communications, were forced to maintain rigid organizational structures. The Battle of Aracourt in September 1944 showcased this contrast perfectly. The U.S. 4th Armored Division faced multiple German Panzer brigades equipped with superior Panther tanks. On paper, the Germans possessed every advantage in armor and firepower, but American radio coordination proved decisive. Every Sherman could report enemy positions instantly. Tank destroyers received targeting data from units they could not see. Artillery observers riding in command tanks called in devastating barrages within minutes. Over 3 weeks, the 4th Armored Division destroyed 281 German armored vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that defied technical expectations. The outcome wasn't about armor thickness or gun caliber, it was about communication. Throughout the war, German intelligence never fully grasped the significance of American communication superiority. Their combat reports often noted impressive American coordination but attributed it to training or discipline rather than technology. A captured German intelligence assessment from September 1944 stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report entirely missed the technological foundation of this coordination. Because of this blind spot, German tactics never adapted. They continued targeting supposed command tanks based on visible antenna arrays, not realizing every Sherman could transmit and receive. They planned ambushes, assuming that once separated, American tanks would lose coordination, failing to understand that FM radio contact kept units coherent, even without visual contact. By March 1945, as American forces approached the Rhine, their communication superiority reached its zenith. The capture of the Ludendorff Bridge at Remagen illustrated the unprecedented speed of American command and control. When the 9th Armored Division found the bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the front were maneuvering to exploit the opportunity. German forces, dependent on wired telephone lines that American aircraft had systematically destroyed, could not respond with comparable speed. American radio coordination created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fire through radio networks. German counterattacks, poorly coordinated because of broken communications, arrived piecemeal and were destroyed one by one. In April 1945, the encirclement of the Ruhr pocket demonstrated the ultimate expression of American communication dominance. Armored columns from the 1st and 9th Armies executed a complex double envelopment entirely through radio coordination. Inside the pocket, 325,000 German troops found themselves trapped partly because their communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication hubs. Wehrmacht units lost contact with both higher headquarters and adjacent formations. Field Marshal Walter Model's final messages before total communication failure revealed the desperate situation. No contact with adjacent units. No communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority also reshaped the psychological experience of tank warfare. Sherman crews fought with the confidence that they were never alone. Even when physically isolated, they remained connected through the invisible network of radio waves. German crews experienced the opposite profound isolation. Cut off from one another, they fought individual battles within larger engagements, unable to coordinate or request support. Otto Carius, one of Germany's most accomplished tank commanders, later wrote in his memoir, Tigers in the Mud, about the challenges of limited communication. Though he focused mainly on tactical aspects, his accounts reflected the loneliness and vulnerability that plagued German tank crews deprived of reliable contact. The strategic implications extended far beyond individual duels. The lightning advances of American forces in 1944 and 1945 owed much to the tempo made possible by constant radio coordination. General George S. Patton's Third Army raced across France in operations that depended entirely on efficient radio networks maintaining control over units spread across hundreds of miles. German commanders consistently underestimated this capability because they could not conceive of communication superiority on such a scale. Heinz Guderian, by then Inspector General of Armored Troops, recognized the issue but was powerless to fix it. In a December 1944 memorandum, he acknowledged that American coordination effectively negated German advantages in tank quality. After the war, American technical intelligence teams evaluated captured German equipment. Their findings confirmed what frontline experience had already made clear. German tanks often boasted superior armor and armament, but catastrophically inferior communications. U.S. Army Technical Intelligence Report number 176 concluded that German tank communication systems were approximately 5 years behind American standards. The report cited the absence of frequency modulation, limited radio distribution, and poor electrical suppression as critical weaknesses. Soviet evaluators reached similar conclusions when examining captured German vehicles. The Red Army, granted access to both German and American designs, chose to model its post-war radio systems on American rather than German technology. Production and deployment statistics revealed the magnitude of the American achievement in wartime communications. American radio production of the SCR-508, SCR-528, and SCR-538 series exceeded 50,000 units. Sherman tank production totaled 49,324 units. This 1-to-1 ratio meant that every single Sherman tank rolled off the assembly line already fitted with a fully capable FM radio system. Each radio delivered 25 watts of transmission power, with crystal-controlled frequency stability to within plus or minus 0.01%. The operational range was about 7 miles while moving and between 10 to 15 miles when stationary. By comparison, German FUG-5 radios, of which roughly 6,000 were produced, offered only 10 watts of power, plus or minus 1% frequency stability, and had a moving range of half a mile to 1 mile, 2 to 3 miles at best when stationary. The statistics of battlefield effectiveness told the same story. The average time required for an American armored unit to request and receive an artillery fire mission was 3 to 5 minutes. For German forces, the process took 15 to 30 minutes, assuming communication lines were intact. 100% of American tanks could coordinate through radio networks, while only about 20% of German tanks could both send and receive messages. The radio superiority of the Sherman tank established principles that would shape modern armored warfare for decades to come. Every main battle tank since has carried a communication suite descended directly from the SCR-508 design. Though today's systems are digital rather than analog, they still embody the same fundamental principles: universal deployment, reliability, and unit-wide connectivity. When West Germany re-established its armed forces in the 1950s, the Bundeswehr made communications a top priority, learning from its World War II failures. Every Leopard tank carried comprehensive radio systems from the start. A Bundeswehr training manual would later state, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts repeatedly validated this lesson. In the 1991 Gulf War, coalition forces equipped with highly advanced communications networks annihilated Iraqi forces using Soviet-designed tanks that were individually powerful but hampered by outdated or non-existent radio coordination. The same principle held true in 2003 during the invasion of Iraq. Network-centric warfare once again defeated platform-centric warfare. The story of American Sherman tank radio superiority thus represents not just a historical curiosity, but a technological revolution. It was a victory fought not merely with steel and fire, but within the invisible domain of the electromagnetic spectrum. German tank crews fought their war partially blind to this revolution, realizing far too late that every Sherman was not just a fighting vehicle, but a node in the world's first networked battlefield. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a vital component of an interconnected weapons system. Together, these thousands of networked tanks created a collective intelligence greater than the sum of their parts. This transformation proved more decisive than any improvement in armor or firepower could have achieved. Every Sherman carried the tools of victory not only in its 75mm gun or its rugged sloped armor, but also in the 181 pounds of radio equipment that connected its crew to every other American tank on the battlefield. This connection allowed them to move, react, and strike with unity. It created a living network of steel that no isolated German tank, no matter how technically superior, could match. German forces discovered this harsh reality through bitter experience, first in the sands of Kasserine Pass, later in the mountains of Italy, across the hedgerows of France, and finally on their own soil in Germany's last battles. In every campaign, American tanks demonstrated coordination that defied traditional doctrines, executing maneuvers that German officers believed impossible without visual signals. The Wehrmacht never developed an effective countermeasure because it never fully understood the scale of the technological gap. Their intelligence analysts observed American proficiency but continued to attribute it to discipline and training rather than equipment. The result was one of the great intelligence failures of the Second World War. Field Marshal Wilhelm Keitel's reported remark at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," captures the fundamental truth of the war, whether apocryphal or not. America had not simply produced 49,324 tanks. It had built 49,324 nodes in history's first armored communications network. What historians today call the revolution in military affairs or network-centric warfare did not begin in the digital age. It began in 1942 when the first Sherman tank fitted with an SCR 508 entered combat. From that moment onward, warfare changed forever. The lesson was clear. The side with superior communications would defeat the side with superior weapons. The network would triumph over the platform. The connected would overcome the isolated. For German commanders, this revelation came too late. By the time they recognized that every Sherman tank possessed communication abilities their own forces lacked, the outcome of the war was already sealed. Despite countless engagements showing that American units coordinated with uncanny speed, the German high command never truly adapted. They continued pouring resources into thicker armor and bigger guns while neglecting the radios that could have made those tanks fight effectively as teams. In the final months of the war, this failure was starkly visible. German divisions often attacked with tanks that outgunned the Sherman, but operated in near-total radio silence. American units, though individually weaker, coordinated ambushes, concentrated firepower, and maneuvered as a single organism through radio-linked command networks. The electromagnetic waves carried by the SCR 508 radios ultimately proved more powerful than the 88mm shells fired by German guns. The ability to communicate, to share information instantly, to fight as a unified organism rather than isolated machines, this invisible advantage determined victory more decisively than any visible superiority of armor or armament. The Sherman's radio system changed the very nature of combat, establishing the enduring principle that in modern warfare, connection equals survival and isolation equals defeat. German troops learned this painful truth across 3 continents, from North Africa's burning deserts to Europe's shattered cities. They learned that the Americans did not merely possess numerical superiority, but technological superiority in the dimension that mattered most: communication. The invisible radio waves linking Sherman crews carried not just voices but strategy, coordination, and confidence. Every tank crew became part of a living network that could think, adapt, and act faster than any isolated enemy. This transformation marked the birth of network warfare. The radios inside the Sherman tanks, unseen by the soldiers who faced them, often dismissed as mundane hardware, were in fact the foundation of modern military dominance. From those humble FM circuits in 1942 grew the global doctrine that today governs all advanced armed forces. Information is the ultimate weapon. When historians look back on the Second World War, they often focus on iconic weapons: the Tiger tank, the Spitfire, the atomic bomb. Yet it was the humble SCR 508 radio, humming quietly inside thousands of Sherman tanks, that redefined the future of warfare. Through its invisible threads of communication, the United States created not just a tank fleet, but a networked army capable of unified action on a scale no opponent could match. The lessons learned in Tunisia, Italy, Normandy, and the Ruhr echo through every modern battlefield. Success belongs not to the strongest or the heaviest, but to those who can connect, coordinate, and command faster than the enemy. The revolution that began inside the steel hull of a Sherman continues to define military power to this day.